So we've had three techniques so far for estimating the area under a curve. And we're going to come up with a fourth one now, which technically speaking is not a Riemann sum, because Riemann sums are calculating the areas of a bunch of rectangles. And what we're going to do this time is we're going to use a shape that's not a rectangle. And we're going to see how that changes things. So this time, instead of using a rectangle, what we're going to use is a trapezoid. And this is going to be called the trapezoidal method. And so once again, we're going to come up with three shapes. Remember that a trapezoid is a quadrilateral that has one pair of parallel sides, and the other pair of sides may or may not be parallel. All right? And so here are our parallel sides. These sides are definitely parallel, and we've got a horizontal line down here. What we're going to do for our fourth side is we're going to connect where the left and right hand points meet. All right, and let me do my darndest to measure that as a straight line. So once again, do you think this is going to be an overestimate or an underestimate, and how good do you think it's going to be? Well, as opposed to the midpoint technique, this looks pretty clearly like it's going to be an underestimate, at least in this case, because all of these straight lines are going to fall under the curve. But on the other hand, this looks like it's going to be a really amazing estimate, because these three areas are all super small. So this is going to be, I think, the best estimate we have yet. So once again, we want to calculate the size of these trapezoids so that we can find their area. All right. So these things all have a common length of 2, and the sides of this are f of 1 and f of 3. The sides of the second trapezoid are f of 3 and f of 5, and the third trapezoid is f of 5 and f of 7. All right. Now let's remember the formula for the area of a trapezoid. When we think about trapezoids, this is kind of our go-to shape for them. But in this case, using them in calculus, this is really much closer to the shape that we're going to have in mind. All right. And so these all have heights, and it has one base, and the two parallel sides are the two bases. And the height is the distance between the bases. And the area is given, it's almost the area of a triangle, but instead of being 1/2 base times height, it's 1/2 height times the sum of the two bases. And the reason for that, if you think about it, is that if you drew a diagonal here, you've broken this into two triangles. The area of this triangle is 1/2 height times B2, and the height of this triangle is 1/2 height times B1. So adding those two triangles together, we just kind of factor out the common term of 1/2 h, and then we're multiplying that by the sum of the bases. Okay? Given that, let's calculate using the trapezoidal method our estimated area. All right, so the first was 1/2. Remember, 1/2 is part of the formula, times the height, which is kind of the width when we've got it twisted like this, and then f of 1 plus f of 3. That's the area of the first trapezoid. The area of the second trapezoid is 1/2 times 2 times f of 3 plus f of 5. And the area of the third trapezoid is 1/2 times 2 times f of 5 plus f of 7. And pulling out that common factor of 1/2 times 2, what we've got is f of 1 plus f of 3 plus f of 3 plus f of 5. That's the contribution from the second trapezoid. And from the third trapezoid, we have f of 5 plus f of 7. Okay? And what we might do is we might collect those like terms together. Some people like this idea better as far as, noticing the pattern, and some people like this method better. F of 1 plus 2 times f of 3 plus 2 times f of 5 plus f of 7. Okay, so what you're doing is, like before, you're thinking about all of the points from 1 to 7, counting by 2, except this time we count the first term and the last term, but all the middle terms we count double, and then we multiply that sum by 1/2. All right, so let's take a look. And this is one of those times when I'm very grateful that my calculator knows the order of operations. So I can just say f of 1 is 6.67 plus 2 times f of 3, which is 8, plus 2 times f of 5, which is 6.67, plus f of 7, which is 2.67. All right, so that gives us a total estimated area of 38.68. Okay, so this is probably, out of them, it's the most complicated one to calculate, but it looks like it's the one that's going to give us the best estimate. So there's a bit of a plus and minus about that. So that is the trapezoidal method. Now, what I want you to do is, once again, I want you to do the same thing using trapezoidal methods, except with 6 trapezoids instead of 3, and see how good that estimate gets. All of these should be in the table that comes after all of these diagrams. You can fill in all of your estimated areas, all of your thoughts, and there's no, judgment about whether it's a high or low estimate. You don't lose points for making a wrong hypothesis when you're putting these things together. But what we're doing is we're getting towards having a better and better idea of what the actual area is. And in the next video, I'm going to kind of encapsulate all of these ideas, and we're going to get towards the idea of how to actually get an excellent estimate, and in the long run, how to get the actual correct answer instead of an estimate.